Since salts that contain either hydroxide or H+, those are ionic compounds known as acids and bases, can be slightly soluble in water, we can use that to calculate the pH of that solution. Here's a sample problem where they ask you to calculate the pH of a solution simply by throwing magnesium hydroxide into water, and they're making a saturated solution of it. A slight digression, it's very easy to make a saturated solution in practice. All you do is take a salt, you throw it in water and make sure you use too much. Give it enough time to equilibrate, filter off all the stuff that did not dissolve, and what's left, right, is that solution, which is by definition saturated. If you just simply keep an excess of the solid underneath, you can have a saturated solution in stock that can just last as long as you want. And it's also, you can imagine, very easy to make it a half-saturated solution. Just filter off the undissolved material and add an equal amount of solvent, and you have half-saturated. So that's a digression. Let's answer this question. What's the pH of a saturated magnesium hydroxide solution given its KSP? Let's think about what happens. We're going to solve for the hydroxide ion concentration, and then we're going to use that to come up with the POH and then the pH. Alright, so magnesium hydroxide gets hucked into water and it forms magnesium cations and twice as many hydroxide ions. Its KSP, which is known, must be equal to this concentration times that concentration squared. That's a simple equilibrium analysis that we've been doing for everything. Therefore, we can solve for S, right? So let's see. The KSP must be equal to S times 2S, quantity squared, recognizing that we form 2 of these for every one of those. S must be equal to 1/4 the cube root of S. So 4S cubed is 1.2 times 10 to the 11th. S is 1.4 times 10 to the negative 4th. That is the concentration of S. Is that the concentration of hydroxide? No, it's simply the S right there. 2S must be the concentration of hydroxide, since there are 2 every one. And so it's equal to 2.8 times 10 to the minus 4th moles per liter. The negative log of the hydroxide concentration, which we're given, is the POH, which is 10.4, which is 3.55. 14 minus that is the pH, and it's 10.45, which is reasonable for this weak base. And it's going to be a pH of 10.45, and we've answered the question.